What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what the Border Gate Protocol is in case you have no idea. So let's get into it. Let's say you're driving across the country from Florida to California. You're passing through state after state, relying on road signs, GPS, and maybe even a few helpful locals to get you from one point to the next. But imagine if none of these systems talk to each other. It'll be chaos, right? Now, think of the internet in the same way. Billions of devices across the world are trying to talk to each other, cross borders, and deliver packets from one part of the world to another. Now, how does all of this work without falling into utter chaos? Well, that's where BGP or Border Gateway Protocol comes in. So in this video, we're going to unpack everything you need to know about BGP, whether you're brand new to networking or already tinkering with routers, and you're going to get a solid understanding of what BGP is, how it works, and why it's such a critical backbone of the internet. All right, so before we get into BGP, let's get one thing straight. The internet isn't one big network owned by a single company. It's actually made up of thousands of smaller networks. Some belong to ISPs, others to governments, universities, cloud companies, or massive corporations like Google and Amazon. And each one of these networks is called an autonomous system. And you could think of an autonomous system as its own mini country with its own rules, routers, and IP addresses. Now imagine these autonomous systems want to communicate. That's where Border Gateway Protocol steps in. It is the language these networks use to talk to each other and share routes. All right, so exactly what is BGP? So Border Gate Protocol, this is a path vector routing protocol that is used to exchange routing information between autonomous systems on the internet. So think of BGP as the GPS of the internet of autonomous systems. It helps them figure out the best path to reach a destination network, and that doesn't always mean the fastest path. Sometimes it's about what's politically or economically favorable. So in other words, BGP is the glue that holds the internet together. All right, so let's bring back this road trip analogy. So let's say you're in Orlando or Autonomous System 123, and you want to travel to Los Angeles, which is Autonomous System 456. Now, there are multiple ways you can get there. You can go through Texas, or maybe you could swing up north through Chicago. And it doesn't matter which path you take because each path might take you through a different set of states, aka other autonomous systems. Now, BGP's job is to look at all of the available paths and help decide which one to take. But here's the kicker. The shortest path isn't always chosen. That's because BGP considers routing policies, economic relationships, and preferences, and not just distance. Exactly who uses BGP? Well, the short answer is everybody with a big enough network. Now, more specifically, we're talking about internet service providers, large corporations with multiple data centers, cloud service providers like AWS, Azure, and Google Cloud, universities and research institutions, government agencies, and content delivery networks. So if you own or manage an autonomous system and you want to connect to another one, whether to buy internet connectivity or peer with other providers or distribute traffic, then you're going to need Border Gate Protocol. All right, so our next question is BGP a layer 4 protocol? So most routing protocols, they live at layer 3 like OSPF and RIP, but BGP actually uses TCP port 179, which puts it at layer 4 in the OSI model. It doesn't send its own messages directly over IP. Instead, it relies on TCP to guarantee delivery. And that means BGP is reliable thanks to TCP. It is connection oriented because the sessions are established between the peers, and it is stateful, which keeps track of the neighbors and the routes that are being selected and chosen. There are two types of BGPs that you're going to often hear about, and the first one is called external BGP, and this is used between different autonomous systems, and this is the BGP that glues the internet together. An example of this would be AT&T and Comcast, where they share routes with each other. And then you have an internal BGP, and this is used within the same autonomous system, and this helps routers inside the same autonomous system share external routes they've learned from other external BGP neighbors. And all internal BGP routers in the same autonomous system, they must be fully meshed or use something like route reflectors in order to pass this information back and forth to each other. All right, so let's talk about exactly how does BGP work. So here's a step-by-step breakdown. The first step is establishing a BGP session. And basically you have two routers called BGP peers or neighbors, and they establish a TCP session on port 179. And then they exchange hello messages, which are technically called open messages, and confirm their identities. After that, they exchange routes. So once the session is up, each router sends the other all the networks it knows about and how to reach them. And this includes network prefixes, autonomous system paths, next hops, and route policies and preferences. Then after they do all of that, they choose the best path. So BGP doesn't just take the first route it sees, it evaluates each one based on a decision process. And then it advertises the best path. So after choosing the best route, BGP shares it with its peers, and this keeps the whole system updated and consistent. Now let's quickly talk about the BGP path selection process. So when BGP sees multiple paths to the same destination, it uses the following rules to pick the best one. First, it evaluates the highest local preference, and this is used inside of an autonomous system. Then there's the shortest autonomous system path. So fewer autonomous systems is equals the preferred path. And then there's the lowest origin type, followed by the lowest MED or the multi-exit discriminator value. Then you have the external BGP, which is preferred over the internal BGP. Then there's the shortest path to the next hop. There's the oldest route, and then there's the lowest BGP router ID. And there are even more steps, but those are the major ones that help BGP decide which path to take from point A to point B. All right, so let's talk about route advertisement real quick as far as filtering and policies are concerned. So one of BGP's superpowers is its ability to apply policies. So let's say you're in a small ISP and you want to prefer Google traffic over Facebook because maybe Google is paying you. And you also want to avoid sending traffic through a competitor's network, or you want to block certain networks altogether. Well, BGP can let you do all of that, where you can apply route maps, prefix lists, and autonomous system path filters. And these tools that will help you shape your traffic exactly how you want it to flow. And here are some key attributes of BGP that you should know. So the first is the autonomous system path. And this is the sequence of autonomous systems a route has traversed. You have what is called next hop, and this is the IP address of the next router to reach the destination. You have what is called a local preference, and this tells internal routers which path to prefer. You have what is called the multi-exit discriminator, and this suggests to neighboring autonomous systems which way to enter your autonomous system. You have what is called the origin, and this shows where the route came from, whether it's IGP, EGP, or incomplete. And then you have what is called community, and they tag routes for policy control. So our next question is BGP secure? So by default, BGP is not secure. It trusts whatever its neighbors tell it. That's how some of the biggest internet outages and hijacks have happened. And a famous example of this was back in 2008. Pakistan tried to block YouTube within its own borders, but due to a BGP misconfiguration, they accidentally told the whole internet to send YouTube traffic to them, and YouTube went down globally. Now, to address this, newer standards like BGP route origin validation, RPKI, and BGP-SEC, they are being rolled out, but adoption is still in progress. And here are some real-world use cases of BGP. So you have what are called multi-horned ISPs, and these are ISPs that connect to multiple upstream providers using BGP to balance traffic, be a failover if one provider goes down, or control inbound and outbound routing. There's also cloud and content delivery. So cloud providers like AWS and CDNs like Cloudflare that use BGP to announce their IP blocks from data centers around the world. You have DDoS mitigation. So security providers that use BGP to reroute traffic through scrubbing centers when under attack. And then you have load balancing. So with BGP, companies can send certain traffic out one link and different traffic out another. Now, while BGP is powerful, it's not perfect. So here are some common issues associated with it. You have what is called route flapping, and this is when routes are constantly going up and down. You have BGP hijacks, and this is a malicious or misconfigured autonomous system that announces someone else's IP range. You have what are called prefix leaks, and this is accidentally announcing internal routes to the public internet. And you have what is called convergence delays, and this is where BGP can take time to recover from outages. And that's why network engineers, they have to monitor BGP carefully, where they use tools like BGP looking glass servers, route views, RipeStat, and BGP monitoring. So exactly what would happen if BGP were to break? So if BGP goes down, large parts of the internet would become unreachable. This will be equivalent to someone deleting all the road signs across the country. And basically, routers wouldn't know where to send their packets, which could lead to websites going dark, cloud services crashing, and major outages all over the place. Now, this isn't theoretical because it has happened before. You can go out there and just Google BGP outage, and you'll find plenty of case studies on this right now. Now, the real question is, should you learn border gate protocol? Well, if you're planning to work in networking, cloud engineering, cybersecurity, ISP operations, or infrastructure engineer, then yes, you should absolutely learn border gate protocol. It's often considered an advanced protocol, but having at least a working knowledge of how it operates, this can help you stand out in the job market because you're likely going to run into BGP on certifications like Cisco CCNP, Juniper certifications, AWS networking certifications, and you're going to hear about it in the Network Plus certification. All right, so let me go ahead and wrap this video up. Border Gate Protocol might not be flashy. It's not the newest, most exciting technology on the block, but it is the backbone of the internet because without it, Netflix wouldn't be able to stream, Google wouldn't be able to load, and emails would not send. Border Gate Protocol, this is like a global agreement between thousands of networks, all working together in a delicate balance of trust, policy, and cooperation. So the next time you hear the words BGP, don't just glaze over it and tune out. Instead, recognize that it is the protocol that makes the internet possible. One route, one peer, and one packet at a time.